Okay, number 8. If the velocity vector of an object moving in the xy plane is given by r prime of t equals sine of t, comma 1 over t, and, there should be an and here, and if r prime of t equal to 1 comma ln of pi plus 2, find the position vector. So we've got two pieces of information. But if it's asking for the position vector, that means that we are looking for the original vector r of t. This point right here is given to us for the purpose of finding c. Okay, that's going to help us find c. Now, in order to go from r prime to r, we have to do the integral. So we are going to do the integral of r prime of t. Integration and differentiation with vectors are done component-wise. So we're going to do the antiderivative of each component. Antiderivative of sine is negative cosine of t. But because I'm doing an indefinite integral, I need to do a constant. I'm going to do a plus c sub 1, because I'm going to have two c's here because we've got two components. Antiderivative of 1 over t is ln of the absolute value of t, and to that I'm going to add another constant, c sub 2. This is going to allow us, now that we have this set up, we can use this point to help us solve for c. So it says that r of pi is equal to, now that means if I plug pi in for t, then the x component will be equal to 1, the y component will be equal to ln of pi plus 2. So I'm going to plug in pi here. I'm going to get negative cosine of pi plus c sub 1 equals 1. And then ln of pi plus c sub 2 needs to equal ln of pi plus 2. This should allow us to solve for c. So over here, I think it's pretty clear. C sub 2 is equal to 2. That has to be the case because it's just ln of pi equals ln of pi. Over here, cosine of pi is negative 1. So I'd have a negative times negative 1 plus c sub 1 equals 1. That means c sub 1 has to equal 0. Now that I know the c values, I can write out a new equation for my original vector r of t. It's negative cosine of t plus 0, which I don't need to write, comma ln of the absolute value of t plus 2.